So the second one is using my truth table. So I will be having the truth table to represent my digital circuits. So using truth table, I can write a Verilog code. For writing this Verilog code using truth table, the model is called as behavioral model. So I don't know the Boolean expression of my digital circuit or the logic structure. Even then I can able to write a Verilog code using this behavioral modeling only with the help of truth table. The other hand is a structural modeling or gate level modeling, where I don't know the Boolean expression, or I don't know the truth table. I know only the logic structure. By using the logic structure of the given gate or any logic diagram, I can able to write a Verilog code, which is nothing but my structural modeling code. So these are the
Sorry,
three.
in that structural modeling,
Hmm.
you still need truth table, right? Like,
No, 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 no need.
oh,
No
like,
need.
then how will be the inputs on the outputs decided?
I'll
Like,
I'll I'll I'll,
okay,
I'll teach you. You
yeah,
need to write only how A is connected to B or B is connected to. So you need to make only how the connection is made. So even
okay,
then you can get the output.
okay,
So
sure,
that is your structural modeling.
okay,
So before going to any programming, you need to know two things. One is your operator and the second one is your operand. So with if you are strong with this operator and then the operand, you can easily write any code. So we'll see what is that operator and what is that operand one by one. Then we'll move on to the syntax of the program and then one by one. So as I already told, general purpose HDL, it is very easy to learn as well as use, and the syntax is similar to C programming, and it has a different level of abstractions to mixed in some of the models. So different level of abstraction is nothing but switch level modeling you can write, gate level modeling you can write, transistor level you can write, or behavioral code you can write. These are the three different methods which I already told. And one more feasibility here is you can mix your gate level with the data flow modeling. So gate level modeling or the structural modeling can be mixed with data flow modeling, but not with the behavioral modeling. So this mixing is also possible in Verilog. So and it is a case sensitive, and it has as I already told, the flip flops as well as logic gates are the leaf cells. So they are inbuilt libraries. So gate level and switch level primitives are already available in the libraries. If you type AND or this ampersand, it will perform AND operation in your Verilog. So this is a comparison between your VHDL and Verilog. So where it has started, how it is started. 1987 in US laboratory it has started, but in Verilog is 1985. So it is a older one than that of your VHDL. So this VHDL is IEEE 1076 standard. It is 1364. Similarly, some different functions are there. The level of complexity, if you see, VHDL is difficult, and here it is average and easy to read. No, PHDL is difficult, it is a lengthy one, and you need to know the entire structure, only then you can able to understand what is the programming flow. But here if you know a little bit, you can able to understand the flow of the program. Predefined features are very poor in VHDL, but in Verilog it is good. So tools are more or less the same. So clock models, it will work for asynchronous, multi-phase, multi-clocks. Both are same, asynchronous, multi-phase, and multi-clocks. So both are common for sequential as well as concurrent statements. And again, a finite state machine also we can write. So there is no semantic for this. Just a simple comparison between Verilog and the VHDL. So this is the syntax of a basic building block. Before writing a code, you need to know the syntax. So the first word will be module. The first word will be module. It should be in small letter, not a capital letter. Module is the keyword to identify that the program is in Verilog model. If it is entity, if you find it is entity, then it is a VHDL. So if it is module, then it is a Verilog code. So once you define a module, you need to give the name of the module. What is the module name? Then followed by its terminal list. Terminal list are nothing but my input and output variables are the operands. So when you are defining this module name, you should not start with numbers. Suppose if it is a 2 cross 1 mux, so you should not start your module name as like this 2 cross 1 mux. Always you have to start with alphabet mux 2 cross 1 or and 21, like this you have to give the name of the module. You should not start with number, always you have to start with alphabets. Then you have to declare the ports or the terminals over here. Then end the modules, module internals. Module internals are nothing but three difference of a programming model, whether it is a data flow or behavioral modeling or structural modeling. We will be writing all the module internals. Then by closing the program, we have to use this word end module without a semicolon and without space between end and module. So the module name is an identifier that is a user defined one, and the module terminals are nothing but my input output terminals. So this is a simple syntax. Let's go one by one, you will get to train what is. So this is the block diagram representation of a module. So first you will have a module followed by module name, then port list followed by port declaration. Port list, suppose you have an AND gate A, B, Y. Y is my output, A and B are my inputs. So here I need to define A, B are inputs and Y is my output as a port list. And here I have to declare which port is input, which port is output, and what is the size of A and B, whether it is a 1-bit value or 2-bit value or 3-bit value or 4-bit value. And if any parameters present, I need to define, that is an optional one. Next, if I go for structural modeling, say this is an flip-flop and this is another flip-flop. So if I connect my structure like this, I have to use wires. I have to use wires. Wires are nothing but general meaning intermediate connection. It is used for connecting between the blocks. So I have to define this particular line as a wire. So this wire also may be a 1-bit value, 2-bit value, 3-bit, 4-bit based on the my first and second blocks. So this is used in my structural logic, not in behavioral or not in data flow model. So next I have to find which modeling I am going to use. So as I already told, if you have a word called module, you can able to find it is a Verilog programming. In Verilog, you have three types. So how to identify those three types? By using a keyword. So if you follow a data flow statement, which is nothing but a Boolean expression. So you have to use a keyword called assign. You have to use a keyword called assign. So whenever you have a program with module followed by assign, which means it is a data flow modeling program. And if you find any always block or initial blocks in the program followed by a behavioral statements are nothing but your case statements. You will be using if statement, if else, while, for, all the nested if. All these statements will be using in only in behavioral modeling. So if you find always statement, then it is your behavioral modeling program. And if you find the lower level instantiation like port map, the word called port map, then it is your structural modeling. Or if you find the connection of your lower module, or if you are calling some subprograms in your main module, if you have some subprograms, then definitely it is your structural modeling. Then if you have any task and function, you have to define. Then finally the end module statement. So this is the flow of your program. Any doubt till this?
No, not now.
So the next one is your ports. So ports are nothing but my input output IO device, which I'll be giving the input and I will be getting the outputs. So which provides the interface to a module and which can communicate to its external environment. So there were three types of ports. One is your input, and the other one is output, and the third one is in out. So if you take input, it is an unidirectional port, only one direction from external world to the simulator or simulating environment, it will get the input, and the output is from the simulator, it will give the output to the external environment. But in out is nothing but a bidirectional port, so it is also called as wire. So as I already shown in the previous one, it is a wire. So this wire is the output of my first block and the input of my second block. So this is a wire. I can define my wire as wire also in out. Both are same as both are bidirectional. So I'll tell as a in out it is a bidirectional because the output of my first stage will be given as the input of next stage. So here it is output and here it is input. So in and out. So as both it is having, so it is defined as in out and also a bidirectional ports. So this is how you need to connect your or write a program for port connections. So this external environment is nothing but our users. So this outside arrow mark indicates the user. If you are defining a wire to the simulator, you have to write as a net. Similarly, if you are writing an input, you have to use a register or net, and the simulator will consider this as a net. So input and output are opposite to each other. So here it is register, and the simulator side or the inside of this environment, this will be treated as register or net. And inside the simulator it is net, and it will be transferred to our outside as a net. So inputs will be given in a register and output will be taken again from a wire. This is a port connection rules.
One second. Uh, while writing the Verilog code, when will we use a wire, and then when will we use the reg type?
Reg will be used in your behavioral modeling. So as because what
Okay.
is a register? What is a register?
Like where the for which the code we are writing, right? Like.
Yeah, one second. So I already told this, and net is used in your structural modeling, right? So you will be
Hmm.
having a structures like this,
Hmm.
and we'll be interconnecting them. It may be
Hmm.
connected here, or it may be connected here, or this may be connected, and you will
Hmm.
get the output. So
Hmm.
this will be my first wire, and this is my second wire, and this is my third
Hmm.
wire. So I can define this W's as net 1, net 2, net 3, or wire 1, 2, 3, 4. So when I go for structural modeling, I will be using this net.
Hmm.
When I go for behavioral modeling, behavior
Hmm.
means I need to cross check the behavior of the person based on his previous activities. So if you take an example of your friend, yesterday he was in good mood, you have cracked the same joke and he laughed, and today you are cracking the same joke but he is not laughing because he
Hmm.
is in some other state. So you have to cross check the behavior of the particular person by knowing his previous state. So in that case, you need to hold what happened now. The recent result is false. So that result has to be stored in a register for a while for cross-checking with the previous data, whether both are same or both are different. If both are same, no issue. If both are different, you have to cross-check. You have to ask your friend what happened to you, right? So when you go for behavioral checking of a circuit, we'll be using this register to hold the output or to store the output for a while for before when how much time it will be pre-checking with the predefined data. So that's the use of this register and net. Very clear?
Yeah.
So next is this basic concepts. What is a white space? So when you use backslash and forward slash this one, which will be nothing but a blank space, and for tab, and this is for new line, and we'll be usually having a commands, right? How to you will
Hmm.
be having a many line of programs. We'll be converting some of the lines, or we have to skip some of the lines, so we'll be using
Hmm.
comments. So if you use double slash, which is nothing but a single line of code, will be converted to a command, single line command. For
Hmm.
multiple line command, we have to use this syntax. So slash followed by a star and the line, how many lines we need to skip at the end of this line, you
Hmm.
have to specify like this. So 1, 2, 3, 4, 5. All these 5 lines now become command line or it will be skipped. So this is your multiple line command.
Yes.
So within multiple line command, you can have single line command also. So this is also possible in this one. And the next one is operator. So I already told you need to know operator and operands. So operands are nothing but your what you call operand
In input output. Yeah.
are the variables. So operators are nothing but the function which we are going to operate between the operand. So here there are three types. One is a unary operator, binary operator as well as ternary operator. So unary operator is nothing but one. Binary means two, ternary means a three. So this operator will perform only with single operand. So tilt of A, which is nothing but you are complementing a register A or complementing the variable A. Suppose A value is 0, after this instruction or after the programming of this line code, this will become 1. Only one operand you have to use. And the binary operator, it is between the operand A and B. So it is nothing but my AND operation. So between two operands, I will be having an operator, that is my binary operator. Ternary operator is for between three operators, between three operands. So take yes as a condition. I need to cross check. I need to ask the question whether the condition is true or false. 1 means true, 0 means false. So 1 means true, 0 means false. So if it is true, it will execute my true statement which is defined at this place. If not, it will define the false statement which is defined here. So this will be my true statement and this will be my false statement. So I will say like this: when s is equal to 0, the first condition will be defined. When s is equal to 1, the second inner condition will be executed. Or when you use a ternary operator, you have to start from left right to left, little India notation. So from this LSB to MSB, the execution will starts. So these are the three different types of operators. So next you need to know how to represent a number. We'll be having different numbers. You should know how to represent a number. So as it is a digital circuits, the inputs will be only zeros and ones. So you have to deal with only the zeros and ones. It may be a 2-bit value, 4-bit value, 8-bit value, or 16-bit value, or 32-bit value, or the power of 2. Power of 2, why power of 2 is it is a base 2 binary. Binary means 0 and 1. So it will be power of n. N power 2 power 0, 2 power 1 like that. You will be having the size of the data. So when it comes to digital, you will be having different ways to represent. One is your binary and the other one is your decimal, octal and hexadecimal. These are the four ways you can represent your zeros and ones. So how to form the syntax for it? First one, your size. What is the size of this data? Suppose 01 means the size is 2. So 1010 means the size is 4 and this is the data. 1010 is a digital data and the size is 4 bit, and this is a digital data and the size is 2 bit. So you have to use this apostrophe to represent it is a size, followed by the base format. These are the base formats. So B means binary, O means octal, H means hexadecimal, D means decimal. Then followed by the number. So if I say it is a 4-bit number, this number should be here. So this is what the number representation in your Verilog. So D for decimal, H for hexadecimal, B for binary, O for octal. So here it is 4-bit binary 111. So 4-bit binary 1111, which is the meaning is it is a binary data of 4-bit. This is the data. 111 is the data. Similarly, it is a hexadecimal 12-bit value, 12-bit hexadecimal data. The data is ABC. So when it is ABC, what will be the size of A, B and C? It is a 12-bit data. So we are representing in hexadecimal format. What will be the size of ABC?
Like it will be like it since it's hexadecimal, it will be 16. Like
Okay, 16 bit, but
hmm,
actually we are using only 12 bit. So it is
hmm,
a 12 bit data, which is nothing but ABC. So size of each will be 4 bit.
4-bit, yeah. Hmm.
A will be 4 bit, B will
Four.
be 4 bit, C will be 4 bit. So we'll get a 12 bit data. So similarly, it is a 16 bit decimal value. The value is 255, 0 to 255. That's the
55
maximum decimal value.
maximum value.
Yes.